Hello.
Hi.
Yeah. You can hear me, right?
Yeah, I can hear you.
Okay. We were doing theory for SHM last class, and let's start doing some problems from the exercises. Okay. There is a couple of things that are left, but we'll come to that once we have done a few questions. So probably in the next physics class, we'll finish the theory. There is composition of SHMs, and there is some damped and forced oscillations, that part. Okay.
Yeah.
But the rest of the stuff is fine. We can start doing the questions already. So have you had time to try anything?
Yeah, I did.
Okay. Do you have any problem?
Yeah, 7, 19, and 28.
Seventh one.
Yeah.
Okay. Question 7. Consider a particle moving in SHM according to this equation. X is equal to 2 cos 50 pi t plus tan inverse 0.75. 0.75. Okay. X is in centimeters and t is in seconds. And the motion is started at t is equal to 0. T is equal to 0, motion starts. Okay. Part A is, when does the particle come to rest for the first time? When does particle come to rest for the first time? So when does velocity become 0 for the first time, right?
Right.
V becomes 0 for the first time. So first you should get the velocity function. After that you can figure out that. So velocity will be differentiation of this, right?
Right.
So it will be minus 100 pi sine 50 pi t plus tan inverse 0.75. I have differentiated with respect to time, right? Because dx by dt is v, correct? So if you notice, this is non-zero at t is equal to 0, right? Correct.
Yes.
If you put t is equal to 0, you'll get sine of tan inverse this and minus 100 pi, right?
Yeah.
So that will be non-zero. So you have to make sure that this becomes 0 for the first time, right? So it will become 0 when 50 pi t plus tan inverse 0.75 is equal to n pi, right?
Right.
So whenever it is n pi, the argument, the sign will become 0.
Yes.
So let's calculate t from here. So t will become, t is equal to n pi minus tan inverse 0.75 by 50 pi, right?
Right.
So now this first time means n should be as small as possible, right?
Right.
So n should be, let's say it's 1, right? So pi minus tan inverse 0.75 divided by 50 pi. So that tan inverse 0.75 is basically 3 by 4 tan inverse, right? So actually this is 3 by 4 is 3 by 5 by 4 by 5. So actually 37 degree, I think. Yeah, 37 degree, right? So pi minus this by, okay, so it is hard to simplify this a little bit here. How is the answer written? Seventh one, answer is given in terms of a value 1.6 into 10 power minus 2. Okay, so let's simplify this a little bit. It is 1 by 50 minus tan inverse 0.75 by 50 pi, right? So this is 2 by 100, so 0.02 minus this thing by 50 pi. Okay, so it is 37 degree, and 37 degree in radian will be pi by 180 into 37, right?
Yes.
Correct. So we'll put that there. Pi by 180 into 37 divided by 50 pi. So it is becoming 37 by 9,000, right?
Yes.
So 37 by 9,000 you have to subtract from 0.02. So let's say it is 36 by 9,000 instead. So it will be 6 by 1500, and that will be 2 by 500. So that will be 4 by 1000, right?
Right.
0.004. You have to subtract from 0.02. So you'll get 0.016.
Yeah.
That is the answer. 1.6 into 10 power minus 2. Right?
Yeah.
So you understand how we have simplified. We have not used calculators. We have just done by common sense only. First, we have recognized that this is 37 degree. And after that, we have expressed it in radians and simplified. And to simplify this, I have assumed it is 36. Approximately 36 by 9,000 is same as 37 by 9,000.
Right. Yeah.
And what have we done for solving the question theoretically? We are equating v to 0. First, you have to get the v function. Only then you can do it, right?
Yes.
And then that part will be 0 when this is multiple of pi. I have taken the first multiple of pi, which is pi. It will not be 0. You cannot put n is equal to 0 because then time will come negative.
Right.
Right? So negative time doesn't make sense here. It starts from t is equal to 0. So B is, when does acceleration have maximum magnitude for? So same process now. B part is saying, when does acceleration have maximum magnitude? So if x is given as some 2 cos 50 pi t plus tan inverse 0.75, velocity is minus 100 pi sine 50 pi t plus tan inverse 0.75. You can get acceleration also by differentiating once more. So it will become minus 5,000 pi square cos 50 pi t plus tan inverse 0.75. Right?
Right.
So what is the maximum magnitude of acceleration? It is just this much, 5,000 pi square. When does it become that? When this part becomes 1 or minus 1. Right?
Right.
It happens at the same time, no? Because this happens, 1 and minus 1 will happen when it is some multiple of pi.
Yes.
It's the same thing that happened in the previous question. At that time, when sine was becoming 0, right?
Yes.
That time cos will become 1 or minus 1.
Yeah.
So that time acceleration is maximum, right?
Right.
Part C is, when does the particle come to rest for the second time? Second time, again, same thing. Make it equal to n pi, but put n is equal to 2,
Yeah.
right?
Right.
Okay. The next one is what? From 7 to 19, there's no doubt.
No.
15, 16 and all you have solved.
Yeah, I
17.
got those. Yeah, 17 was there in Francis as an example. So.
But do you know the way to do it properly?
Yeah.
So generally, when you have to solve SHM questions, you have to displace it a little bit from the equilibrium. Okay. So if the mass is like this, what you are doing is, there are two springs K1 and K2, and this is M. What you have to do is, right now it is in equilibrium, but displace it slightly by some X amount, right?
Right.
If you displace it slightly and bring it here, that time now measure restoring force. So restoring force due to this spring will be K1x and due to this spring will be K2x, right?
Yeah.
So total restoring force will be K1 plus K2x, right?
Right.
Once you get this, then it is fine, because Now acceleration is equal to minus of k1 plus k2x by m. This I have put minus sign because displacement was this side and force is this side.
Right.
And now you get that this is my omega square. So time period will be just simply 2 pi by omega, which is omega is now it becomes this.
By just A2.
Yeah. So generally while solving questions of SHM, the force method says that displace it a little bit from equilibrium, little bit from its equilibrium position, and then check all the forces or torques that are there at that moment. Equilibrium position, check forces and torques, forces slash torques, and you should get that restoring force is proportional to x or restoring torque is proportional to theta. If you get that, the constant of proportionality, this part becomes the k, and then acceleration is k by m, right?
Right.
Into x. So minus k by m into x, and then you can get the time period. So that is the force method of solving SHM questions. So let's apply that to question number 19. Question 19 says there are 3 springs. One is like this. There's a body, and one is like this. This angle is 45 degree. This angle is 90. This is B, A, and C. Now, if the particle is pushed slightly against spring C and released, pushed slightly against spring C and released. So then what is the time period of oscillation? Okay, so let's move it by a certain amount. Let's take first origin like this, and this is my negative 45 degree, right? This is in third quadrant.
Right. Yeah.
And we have pushed it slightly along this by some slight distance. That distance is, let's say, x, right?
Yeah.
So my particle is now at the position minus x by root 2 comma minus x by root 2, right?
Yes.
Because cos 45 sine 45, right?
Yeah.
So now I need to find out what are the restoring forces on the bob on the mass m here, correct?
Yeah.
So there will be this spring has become stretched like this, right? And this spring has become stretched like this, right?
Yes.
Correct.
Yeah.
So okay, so what you can say is, if I can find extension or difference between this length and this length, right,
Yeah.
then I will be done, right?
Right.
Correct. So I know this length of side, this no x.
Yes.
So okay, and I know this was natural length L earlier, right? So I have a triangle like this, right?
Yeah.
This angle is 135 degree, correct? This is
Correct.
L, this is x. I need to find this, right?
Yes.
And then what I need to do is, this is new length L dash, and I need to say L dash minus L is my extension, right?
Right.
Okay.
Right.
Now this is a simple question. It is cosine rule in this triangle, right? So you can say cos 135 will be equal to x square plus L square minus L dash square by 2xl, right?
Right.
So therefore cos 135 is actually minus 1 by root 2. So minus 1 by root 2 into 2xl is equal to x square plus L square minus L dash square, right?
Yes.
So you get L dash square is equal to x square plus L square plus root 2 XL, right?
Yes.
Okay, so this is my L dash square, and L dash is just root of this, right?
Right.
Root of this, and you have to find extension, which is basically subtract L from this. So L dash minus L is equal to root of x square plus L square plus root 2 XL minus L, right?
Right.
Correct. So now, so you have to simplify this a little bit. You know that x is less than L. He said small displacement, right?
Yes.
So I can take L square common outside, and it becomes L into x square by L square plus 1 plus root 2 x by L, right?
Right.
Minus L, right?
Right.
This is my delta x. So now I'll ignore this part, right? And I will write it as this only, right?
Right.
You understand? I can ignore this, right?
Yeah.
So I'll say L 1 plus root 2 x by L to the power half, right? Minus L, right?
Yes.
This is my current extension, no?
Yes.
Now binomial theorem I will apply. 1 plus x to the power half can be written as 1 plus half into whatever this is plus more terms, but more terms will have this one will be squared, right?
Yeah. So can be neglected.
So I can neglect that, and L minus L, right? So
Right.
finally LL will cancel, and what will be left is 1 by root 2 x, right? See, this will cancel this part, and it is 1 by root 2 x, no?
Yeah.
That is the extension, okay? So x by root 2 is my extension, and force is in this direction, right?
Right.
Force is in this direction, and this force is also going to be in this direction. These are pulling forces,
Yes.
right? So I need to actually get the resultant of these two and the resultant from this one, right? This is pushing, right?
Right.
So
Right.
force here will be kx by root 2, and this will be kx by root 2. So what I need to do is cos of this angle, right? Kx
Yeah.
by root 2 cos of this, kx by root 2 cos of this, and double it, right?
Right.
So cos of this angle, now this angle, how do we do cos of this? We can do it. We can take, this will be a tiny angle, so, but fine, we'll just do it properly. Cos of this angle, again cosine rule we can do, right? So 1 second. X L L dash, and we know L dash is equal to almost equal to L plus x by root 2, right?
Right.
Correct. So this angle theta is basically, okay, it's fine only. We can do sine rule actually. So x by, this angle I don't know, so I will not use that. I'll say L by sine theta is equal to this by sine 135, right?
Yeah.
By sine 135, correct?
Yes.
So I will get therefore sine theta is equal to L sine 135, which is L by root 2 by L plus x by root 2, right?
Yes.
So sine theta is coming as L by root 2 L plus x, right?
Right.
Um, okay. So this is basically 1 by root 2 plus x by L, right?
Yeah.
Correct.
Yeah.
So sine theta is this. So fine. Cos theta is what? or root over 1 minus 1 by root 2 plus x by L whole square, right? Correct. So this
Yes.
is root 2 plus x by L whole square minus 1 by root 2 plus x by L whole square. So cos theta is coming out to be, inside the root it is 2 plus x square by L square plus 2 root 2 x by L minus 1 by root 2 plus x by L. So this becomes 1 plus 1, and this I can ignore, x square by L square. So I get 1 plus this thing and root 2 of that, right? Root of that. So cos theta is becoming 1 plus 2 root 2 x by L to the power half by root 2 plus x by L, right? And now you will see that this is almost same as this, I think. 1 plus 1 by 2 into this. No, it's not the same, but okay. It is coming 1 plus root 2 x by L by root 2 plus x by L, right?
Yeah.
Approximately, this is my cos theta, right? So it
Yeah.
is almost same as 1 by root 2 approximately, because 1 and this part will be small and root 2 and this part will be small. You understand what I'm saying? X by L is small compared to 1,
Yeah.
and similarly it is small compared to root 2.
Right.
So it is close to 1 by root 2. So what we are getting is this force and this force are kx by root 2, and these thetas, cos theta and all, is 1 by root 2. Therefore kx by 2 is approximately along this line, right? So another kx by 2. So it becomes total force is kx, right?
Yeah.
From these two springs, and from here also there is a kx, right?
Right.
It becomes 2kx is restoring force, and 2k by m basically into x is acceleration. So omega square, omega is coming as root 2k by m, and time period will be 2 pi by root m by 2k, right? You understand?
Got it.
So the method of solving was a little long because the question is not very straightforward, in the sense that you have to think of what are the steering forces along this line and this line, right? So what we did was just found out the length and found out cos theta and all.
Yeah.
If you use some things like 135 this is, and if you say that this angle will be 45, then it will be very easy, because this angle will be close to 0 only, because the line is displacing very little, no? This angle should be close to 0.
It is.
You understand? Actually you are
Yeah.
going along, you have just created a very small triangle, no? Because you have gone very small distance, right?
Alright. So that would be negligible.
Just hold on for a second. Yeah. So what I was saying was you have gone a very tiny distance. So this angle is close to 0 actually. So we could have done this if we had made that assumption that this is close to 45, then it would have been easy. But I just wanted to show that normally also if you do, you will get it. Like if you follow a regular process of in this triangle, find this angle and stuff, after doing some binomial approximations, you get the answer. So kx by root 2 and 1 by root 2 we multiplied to take components along this line and then added the kx that comes from here. Right? Okay. That was this one. Question 21 you've done.
Yes.
How did you do 21? Without using formulas, have you derived the formulas or have you done by some formula?
I just want K equivalent.
But that is a formula. So how do you know that it is correct, that formula? K equivalent is a formula, no?
Yeah.
Series, parallel and all you have done.
Right.
But who, like, there is no proof for that, no? How do you know that it is correct? So man is exerting a constant force of F on the block and amplitude and frequency of the motion. Okay. Frequency of this motion. So first, basically frequency is time period you have to find. So first, to find time period, you need to figure out what happens to this system. Without using a formula, how will you do it? You have to displace it by some amount. Let's say we displace it by an x amount. So restoring force due to this is k1x, and restoring force due to this system is different now. The problem is that there are two springs, right?
Right.
There are two springs and I don't know how much each spring is extending, right?
Yes.
Let's say this is K2, this is K3, and total extension was X. X was the total extension. So let's say K3 spring is extending by X3 and this spring is extending by X2. So you should have X2 plus X3 is equal to X.
Yeah.
Right?
Yeah.
And the actual restoring force that the block faces is going to be K3X3, right?
Right.
Because it is connected to the K3 spring, not to K2.
K2, yeah.
So it will actually face a K3X3 force, that is clear. So total restoring force, F restoring, is equal to K1X plus K3X3. Right?
Yeah.
What you need to do is express this K3X3 in terms of X, right? Somehow.
Right.
Right? So we know this result because this spring will also stretch and this spring will also stretch. This will stretch by x2, this will stretch by x3, and we know this result. So now what? How do you express x3 in terms of x without using any x2 and all, in terms of just x, right? So for that, you need to understand that at this point, think of the forces at this point in the middle here, right?
Yeah.
It will be pulled by this spring with a force of K2X2, right?
Right.
And this spring will pull it by K3X3.
X3. Yeah.
So what you will get, otherwise they have to be equal because otherwise this point will break this spring.
Great. Yeah.
So K2X2 should be equal to K3X3. And now you have a nice way to connect it. You have X2 plus X3 is equal to X. And you have X2 is what? X2 is equal to K3X3 by X2 by K2. So now you put that here. K3 by K2 X3 plus X3 is equal to X, right?
Right.
So X3 common 1 plus K3 by K2 is equal to X. So therefore, X3 is becoming X into K2 by K2 plus K3.
You're right.
X3 has come. So now K3, X3 will come. So therefore, F your F restoring is becoming K1X plus K3, and X3 is K2X by K2 plus K3. Now you are getting that formula that you have used.
Yeah.
Right?
Yeah.
So don't use formulas that you cannot derive. Okay, like that is a basic thing. Like you cannot use something that you don't know how to derive.
Right.
Like if you use something and you don't know how it is coming, then what is the point? Then that is like taking just trusting on based on faith basis you are doing. No, that is not science too.
Yeah.
So make sure that if you're using something, you know how it comes. So this part you need to be clear on why it became this equivalent. So now you can see, once you have derived it once, you can see that if it was in series, you are getting like a parallel resistor situation.
Yeah.
Just like parallel resistors, you take 1 by R1 plus 1 by R2 is equal to 1 by R equivalent. You are doing that only here. And when you replace it with this K2 K3 by K2 plus K3, you have two springs which were in parallel, and that time it gets added. Just like in series connection of resistors. Right?
Yes.
So K equivalent can be obtained by doing the opposite of what you would do if they were resistors. You can think of resistance formulas and the opposite. So when it is in parallel, you add, and when it is in series, you do 1 by R1 plus 1 by R2.
Yep.
Now the answer will come, time period and all will come very easily, frequency will come, right?
Yes.
But make sure that you know your stuff, okay? Don't assume anything and go ahead and do things.
Got it.
Okay. Then the doubt was which one?
24th.
Okay. 24th one is, there's a pulley, there's a spring and a mass M, K, and pulley has a moment of inertia I. I is the moment of inertia of the pulley. String does not slip. String does not slip over it. So actually in the previous problem, string was slipping and pulley was light and all, right? The
Yeah.
previous problem was just the rope is itself sliding across it. But
Yeah.
now the rope will not slide across it or slip across it. It will rotate the thing, right?
Right.
So it will rotate the thing. So now you have to figure out using torques and all what is the situation here. So you leave it here, it will try to come down by some amount. Now there are two ways to do this question. One way is by force method. If it comes down by X amount, what is happening, right? But force method is a little harder here. What you should do is energy method. So I'll show you how to do by energy method. Energy method of solving is, at a general point, you should write total energy. At a general point, write the total energy of the system. So once you write the total energy of the system, you can say that du by dt should be 0, right? If it is SHM.
Yes.
Total energy is constant, right?
Right.
So let's say the initial equilibrium position was my 0 level of gravity, like this, right? This is, let's say gravity is 0 here, gravity. And it will fall down by some X amount, okay? Correct?
Right.
It falls down at some X amount, it acquires some speed in that process at that moment, right?
Right.
and the spring gets stretched by some amount. Spring should get stretched by X amount only, right? Because rope cannot extend itself, no? If this comes down by X, spring has to go up by X, right?
Yes.
Correct, no?
Right.
Total energy of the system will be energy of the spring, which is half kx square, plus energy of the mass, which is half mv square. It has acquired some velocity at this moment while falling down, but it has also gotten a slightly negative potential energy, right? Minus mgx, right?
Yes.
Because you took the zero level of potential here, right? And it will also have half I omega square for the pulley.
Yes.
Pulley will be rotating, and I omega square will be the energy half I omega square. Also, we have a relation that V should be equal to omega into R, right? Radius of the pulley. Because it has acquired some velocity, that means this point is moving down with V. So V should be omega into R, no?
Right.
Correct? Because it is not slipping, right? Pulley is also turning with an equal angular velocity, right?
Yeah.
So this is the total energy expression now. It has spring energy, it has mass, kinetic energy, potential energy, gravity, and rotation, kinetic energy of pulley, right? This is the total energy of a system at a random point. Now I'll do d of t by te by dt is equal to half k 2x dx by dt is velocity plus half m 2v dv by dt is acceleration minus mg velocity plus half I 2 omega dw by dt is alpha, right?
Yes.
Correct?
Yeah.
So this part is supposed to be 0. So you get some simplifications. You get kxv plus mva minus mgv plus I omega alpha, right? Correct?
Yeah.
So now realize that V is equal to R omega implies A is equal to R alpha, right? So
Right.
alpha is equal to A by R, right? R is radius of the pulley,
Right.
correct? No?
Yeah.
So, okay, 1 second. So something is wrong with my thing. Alpha is equal to A by R. So I will just rub off this a little bit and write what happens here only. So okay. So you have kxv plus mva minus mgv plus I omega. Omega is what? V by R, right? And alpha is A by R, right?
Yeah.
Is equal to 0. So collect all the A terms, right? Correct. Collect all the A terms. So notice that V will get cancelled from every term, right?
Yeah.
So you have A m plus I by R square minus mg
Plus K. X.
plus kx is equal to 0, right?
Right.
Okay. Minus mg plus kx, yeah. So this minus mg is slightly annoying. So you're getting A m plus I by R square is equal to mg minus kx, right?
Yeah.
Correct.
Yeah.
So acceleration is, this is a constant, by the way, right? M is constant, G is constant, right? So this is acceleration is coming constant minus kx by m plus I by r square, right?
Yeah.
Correct. So notice that even though this is a little bad that it has come constant minus this, but still it is proportional to minus of x, no?
Yes.
Like you are generally you are supposed to get something like this, but there is a constant here, extra constant, right? That constant is, I think, because we have chosen the that constant basically determines how much is the amplitude and all, and we have chosen it at that point, the u is equal to 0 and all. So we cannot get rid of that, but we're getting that acceleration is still proportional to minus x, right?
Yes.
And that part, the part of constant of proportionality is this omega square, right? K by m plus I by r square, right?
Yeah. Yeah.
So time period will be 2 pi by omega, where omega is root over k by m plus, wait, what? K by m plus I by r square. Correct. Right? So
Yeah.
you should get 2 pi root over m plus I by r square by k is your time period. This should come. Right?
Yeah.
So this will come. Notice that we saw here that if acceleration is some constant minus k x, right, then it still works. This k is your omega square. That is still SHM. It's just that it has some starting value which was not 0 when x is 0, right? This constant is just saying that initially there is some acceleration and after that there is an SHM component, right, which keeps varying.
Right.
So this is also SHM. It's not a problem because still you are getting A is proportional to minus kx. So this is energy method. You should apply energy method in some of these problems. Whenever it seems very difficult to do by forces, energy method is the solution. Okay.
Okay.
What else? There is some other question also, I think.
Yeah, 25th and 28th. That's it.
25th and 28th. Okay. Question 25 is having two masses. Okay. Two masses like this. This is M, this is K. Show that if the blocks are displaced slightly in opposite directions and released, they will execute SHM, calculate time period. Displaced slightly in these opposite directions and released, right? They will execute SHM and calculate time period. See, here the problem will be that force method will be slightly annoying again because the forces will be on two of them, no? So
Yes.
it will be slightly weird to track two masses displacement. So I will just do it by energy method again. I will say when it is displaced slightly and it is coming back now, right?
Yeah.
Let's say it is at some intermediate point. Let's call this initial displacement x0 x0, okay? And so it reached here. This was x0 x0, okay? So it has been displaced by x0 here and x0 here. And let's say there is an intermediate position when its displacement is x and x, right? You realize that the oscillation will be such that they will be first going like this and they will keep oscillating in this manner, right? Like this, right?
Right. Yeah.
Correct. So I'm talking about a point when the actual displacement from the mean position is x and x for both, right?
Okay. Yeah.
This is the mean position when it was natural length, okay?
Yes.
Then you have displaced it by some larger amount actually and then left it, right?
Yes.
So then it will come back towards itself, no, toward inside, right?
Yeah.
Now notice that this is an isolated system. There is no external force on this system, right?
Yes.
So center of mass will remain at rest if it was initially at rest, right?
Yes.
And initially you can see that VCM is 0. So finally also at any point VCM must remain 0, right?
Right. Yeah.
That will mean that if this is moving at V, this is also moving at V because they have equal masses.
Right. Yeah.
Then only VCM is 0, right?
Yeah.
So at any point, arbitrary point, I can say, and also that means that whatever is the displacement here x, this will be same displacement here x, right?
Yes.
Because otherwise center of mass will change position, no?
Yes.
Initially when you released it, you gave them equal small displacements, right?
Right.
So initially you have not changed center of mass position, so it will remain fixed. So basically what I'm saying is this one is also displaced by x amount and this one is also displaced by x amount, which is equal, right?
Right.
And they have same velocity v at that moment, right?
Yes.
So if you think about it, actually the spring is stretched by 2x amount, no, at this moment, because
Yeah. Yeah.
one side is x, one side is x. So
It's
total energy, if you write, spring energy will be half k 2x whole square plus the masses have some kinetic energy, right? Potential energy and all is not necessary here because there's no gravitational potential energy change happening, right?
right.
So kinetic energy will be half mv square and double of that because the other one also.
Yeah.
There is no other energy. We have already put the spring energy and potential energy. That's all, right?
Yes.
That is equal to U total energy. And so this becomes half into 4x square. So 2kx square plus mv square is equal to U. So du by dt will be equal to 2k into 2x. So 4kxv plus 2mva, right?
Yes.
Correct. So this should be 0. So 0 is equal to 4kxv plus 2mva. V cancels and you get A is equal to minus 2kx, right, by m, right?
Yes.
So this is your omega square and therefore time period is 2 pi by omega, which is root m by 2k. Check once. Correct.
Right.
You understand what we did, no?
Yeah.
We wrote total energy, we differentiated it, said it should be 0, and we got this expression, which is the A is equal to minus omega square expression, right?
Yeah.
How did we write total energy? We took at an arbitrary point when the displacement was xx. So that will have spring will be extended by 2x and kinetic energy will be V and V, so 2 times, right?
Right.
So this energy method is quite useful. Also, this system, you will realize that in an earlier chapter, there was this reduced mass concept somewhere, I think in rotation or something. And this concept is coming again. So whenever you have two springs, right, connected by some spring and two masses connected by one spring, right?
Yeah.
So actually this system's behavior will be equivalent to one mass connected by a spring. One mass connected by a spring, and this mass can be written as m1 m2 by m1 plus m2. Okay. If this is m1 and this is m2, and in this case m and m were same, right?
Yeah.
So this becomes m by 2 in this case. Reduced mass was m by 2 in this case. So suppose you had a one mass system with this situation, right?
Yes.
And then oscillations of this would be very simple, no? 2 pi root m by k. So m by 2k, right?
Yeah.
So that is a trick, that two masses connected by a spring can be expressed as it is going to exhibit the same behavior as one mass connected by a spring, but that is a reduced mass, which is m1 m2 by m1 plus m2, which is m by 2, which is coming, time period is coming, right? But this is a trick method. Like You use it only in this specific case. Normally, the way I derived it was not by this method. I derived it by energy method, right?
Yes.
It is coming from there. Okay, the same answer is coming. Correct?
Correct.
Next one is 28.
Yes.
Okay. Question 28. This is the situation. There is a spring connected to a mass m, and there is another m somewhere here. The whole distance, this much, is L, and this is coming at V. Moves at V towards right block. Right block is kept in equilibrium, though no extension right now. And all collisions are elastic, surfaces are frictionless. So show that the motion is periodic, find the time period of these periodic motions. Okay. So fine, all collisions are elastic. So it will come with V, and this is also mass m, right? So when it hits, this one will acquire a V and this one will be stationary, right?
Yes.
Velocities will be exchanged, no?
Yeah.
So this one suddenly acquires a V. So it will go inside and come back to this point, right?
Right.
Time period of its motion is 2 pi root m by k, right? It will do SHM. Basically, it's like a simple spring mass system, right? Where you have given a V to it, right? Correct?
Yeah. Yes.
Its time period will be 2 pi root m by k, and its equation of motion okay, equation of like, I just want to find out how much time it comes to come back here, right? So actually that is time period would have been if it did went inside, came back, and then it would have wanted to continue here and then come back, no? Actually, what would happen if you give something a velocity at the mean position? It will go till somewhere here, stop, then return here, and then come here and stop, and then return here, right?
Right.
So if you think of one time period is from here to here, then till here, and then till here, right?
Yeah.
So you are going only till this much, right?
Right.
Because then you will collide with the first block, right?
Yes.
So this is basically t by 2, no?
Yes.
You understand? This is t by 2 of the whole time period, no?
Yeah.
So therefore, after time pi root m by k, it will come back, right?
Yes.
Pi root m by k. So let's start measuring our time from this moment, first collision, okay?
Okay.
Let's start measuring when first collision happens. After that, we'll start measuring when the system repeats itself, right? So pi root m by k is first time that came. Then this acquired a velocity of v, right?
Yes.
So then when it collides back, the first block again goes back with v, right?
Yes.
And this one suddenly came at rest now, right?
Right.
And it will come here in time L by V and come back here in time L by V. So T2 is basically 2L by V, right?
Right.
And then second collision happens, right?
Yes. Yes.
So basically in this much time from first collision to second collision, now the situation is a repeat of the first case, right?
Yes.
So pi root m by k plus 2L by V is the time period of this periodic motion. Obviously it is not SHM, right? It is a periodic motion, right? Part of it is an SHM, a little part of it here, right?
Yeah.
After that, it is periodic. So let's just check that, right? Makes sense. This is correct. You understand what happened, how we did it?
Yeah, I got it.
We started measuring time when first collision happened, and then you see that total time period would have been this, but that would have been the full full motion, right? Full cycle. But actually it cannot do that. It only has to do this much, right? Which is half cycle.
Yes.
So that is time period by 2. And then the block collides again and this goes here and returns back in 2L by V. Then the whole cycle repeats once more. So total time period for the periodic motion is just this, right?
Yeah.
Okay. So fine. So try the rest of the questions here. Next class, what we'll do is we'll start off with the theory part where we finish the composition of SHM's part, and then we'll continue with the problems from the exercise. Okay.
Okay.
Tomorrow we'll do chemistry, morning only. So we will start that CC bonds using organometallic compounds, the chapter after acidity basicity.
Oh, okay.
Okay.
Yeah.
Acidity basicity, you just have to read 3-4 pages. It's not a big deal. You should understand it. Okay. But we will start the chapter 9.
Yeah.
Okay. I'll see you then tomorrow.
Thank you.
Bye.